And this video brought to you by Advanced Compliance for your acceptance testing needs. Certified bed bug free since, well, we'll just say certified bed bug free.
Hi, my name's Bob Shearer, and today we are going to look at trimming in a multi-level area control on a 0 to 10 volt system. I have a 0 to 10 volt ballast here. I have a CFL inside this carefully calibrated cardboard box. I have a meter to read the control voltage straight off the terminals of the control device. There are the leads. And I have a light meter to read the output from the lamp. And so we will be taking this control and basically trimming it in so that it's more responsive and gives you a fuller control over the dimming from top to bottom. We happen to be controlling an LMRC 213 room controller, and we are using an LMDM-101 switch as the multi-level area control. Doesn't really matter what you're doing. If you have a 0 to 10 volt system or even digital, you need to characterize it and you want to trim it throughout so that you get the best response from the system and it looks like the most professional job.
So what do we mean by trimming in the control? I have a voltmeter to show me my control voltage. I have an area control all the way up. I've got just about 10 volts even here and 1,000 foot candles from my calibrated cardboard box. This multi-level control has 7 indicators on it, each capable of dimming down halfway. In fact, I'm going to hold this button down and count to 2 fast. 1, 2. I've taken out the top indicator completely and we are still at 1,000 and change. So let me take it down a little bit more. 1, 1. I have 2 top indicators out and the same reading on the light meter, so 2 of my 7 indicators for dimming are already out. Let's take the next one out. Oh, there we go. Now I'm seeing a little bit of dimming. So let's see if we can find out where the top of our dimming range is on this switch. As you can see, 2 out of 7 have already been extinguished with no dimming action at all. And that's a fair amount. When you consider there's about 14 different indications that can be shown here, having 2 out completely is quite a bit with no dimming. Okay, pushing this down for a quick count of 3 begins to show some significant dimming, or at least some dimming, and our control voltage is all the way down at 7.3 volts. What about the bottom end of the switch? So let's take this down some. Alright, we're down pretty far. We've got about 78 foot candles. And we'll take another dot out. We've got about 50 foot candles. And we'll take it all the way down and we've got about 40 foot candles. So basically 40 to 50 foot candles out of 1,000 is not very much. That's 10 foot candles, so that's 1/100th of the dimming range down at the bottom that we really don't need to leave there, 1/100th. So what's happening, and let's check the voltage. Our control voltage is about 1.5 volts. So between 1.5 volts and 1/4 volt, we only see 10 foot candles. I don't know that we need to waste a spot on that. So we want this thing, which has a response, which has a command about like that. It's affecting a luminaire that has a response about like this. Well, wouldn't it be nice if we could even these up and get full response out of our dimming control versus somebody going 1, 2 and nothing happening, 3, nothing really happening, So the first thing we want to do is try and find out where the top of our dimming range is control voltage wise. So let me hold it down. Okay. And oops. Let's take her down again. It's this persnickety control. It's below 8.6 and above 7 and below 8, 7.5 is maybe showing us a little dimming. Yes, so we'll call it 7.5 on the top. Now on the bottom, well, we already knew that it was sitting at about 1.5 volts, I think, to give us our 50-foot candles. Right? Right? Yeah, I'm going to pick about 1.5 volts. So we're going to set the upper and lower ranges of this so that we get better action. So turning on our handpiece, the first question we need to ask ourselves is, when I tell the system a certain percentage, how does that relate to the control voltage coming out? Because we know we want to be somewhere a little above 7.5 and maybe somewhere a little below 1.5 volts. So there we go. We're hooked into this circuit, and we are going to set the high trim for 50%, and we'll see if we get 5 volts out of the controller, because that's a very good spot to check. This will tell me, basically, as far as I'm concerned, that whatever I put in as a percentage is going to directly relate to the control voltage out. So let's take her down and take it back up and get a look at the control voltage, and it's 5. So for a 50% setting on the top end, we've got 5 volts. We can assume that we can relate the percentage to our control voltage. So I've selected slightly under 1.5 volts, which is where we're stopping having significant dimming on the bottom, to slightly above 7.5 volts, or 78% on the top end. So I'm going to set this for 78 on the top percent, 7.8 volts, and I'm going to set it for 1.2 volts on the bottom. So let's send that. And see how that looks on both our control voltage and dimming. 7.8 volts, just what I was shooting for. Let's take it all the way down, and we've got just about the 50 we were shooting for at 1.33 volts on the bottom end, which is a very nice thing. So let's take it all the way up to the top again. Alright, it's looking like I've got about full output here, but now when I push the button and count 1 fast, 1, no dimming, 2, there we go. So I could put it a little closer on the top end, but you get the idea. There's no longer a very long wait to see dimming action occurring, including going up. I'm almost immediately going to see the lamp increasing, and on the top end, well, I could take another dot out, I suppose. There's 1 dot out, full up, 1 dot out. You know what? That looks about right. This way you get more of a proper range on the area control, which it's not a legal requirement, but it's kind of like part of a good job, if you ask me. Oh yes, one double check on a system like this to make sure that when you have taken the multi-level control all the way up, to check that it is all the way up, is to unplug the 0 to 10 volt control line. I've got 976 or so. and I've got 976 or so. So plugging or unplugging the plug is not really making any difference at all, meaning that we are fully all the way up, and now we have a much more sensitive dimming range that starts out right away, and the room occupant doesn't have to sit and wait for the lighting to begin to dim when they hit the switch. So let's contrast this with an old-fashioned slide dimmer that you can only trim the bottom on it. I'm sitting at the very top of it and bringing it down and bringing it down, and I'm seeing my control voltage at 9.9 foot candles full. Alright, 9 foot candles full. Up. About 7.75 foot candles full. And there we finally see some dimming action. I'll mark that spot. And then let's take it down near the bottom. And 86, 60, 50. I'm all the way up there. 39 or 40 is as far as it goes down, so that's only 10 foot candles out of about 1,000 right there. So we'll go and do what we did with the other switch, and we will put the thing at about 50 foot candles, okay, which is a difference of 10 up, which would be 1/100th of the 1,000 foot candles at max. And you can see that the actual dimming range, the effective dimming range on this dimmer, is basically between there and there. And because this is not, and then this only takes it down 1/100th of the output. So not really an effective thing. So that's actually the effective high quality range on this dimmer. And this one cannot be tweaked like the digital dimmer. So that's what the beauty part of a digital system like this is, with a 0 to 10 volt ballast or driver.